Welcome to Wormhole to Cosmos, where we journey through the wonders and mysteries of the universe. Today we explore an astonishing cosmic phenomenon, one that could reshape our understanding of how stars live, die, and influence the planets around them. What happens when a star reaches the end of its life? The story goes far beyond what we once believed. Stay with us as we dive into new discoveries that could change the way we think about the fate of worlds across the galaxy. Buckle up because space has surprises in store, and we're about to uncover one of its most shocking secrets. An exploded star can pose more risks to nearby planets than previously thought, according to a new study from NASA's Chandra X-ray Observatory and other X-ray telescopes. This newly identified threat involves a phase of intense X-rays that can damage the atmospheres of planets over 100 light-years away. Although Earth is not in danger now, it may have experienced such X-ray exposure in the past. Before this study, most research on the effects of supernova explosions had focused on the danger from two periods: the intense radiation produced by a supernova in the days and months after the explosion, and the energetic particles that arrive hundreds to thousands of years afterward. However, even these alarming threats do not fully catalog the dangers in the wake of an exploded star. Researchers have discovered that in between these two previously identified dangers lurks another. The aftermaths of supernovae always produce X-rays, but if the supernova's blast wave strikes dense surrounding gas, it can produce a particularly large dose of X-rays that arrives months to years after the explosion and may last for decades. The calculations in this latest study are based on X-ray observations of 31 supernovae and their aftermath, mostly obtained from NASA's Chandra X-ray Observatory, Swift and New Star missions, and ESA's XMM Newton. The analysis of these observations shows that there can be lethal consequences from supernova interacting with their surroundings for planets located as much as about 160 light-years away. If a torrent of X-rays sweeps over a nearby planet, the radiation would severely alter the planet's atmospheric chemistry. For an Earth-like planet, this process could wipe out a significant portion of ozone, which ultimately protects life from the dangerous ultraviolet radiation of its host star. As far as anyone knows, the Earth is not in any danger from an event like this now. However, it may be the case that such events played a role in Earth's past. There is strong evidence, including the detection in different locations around the globe of a radioactive type of iron, that supernovae occurred close to Earth between about 2 and 8 million years ago. Researchers estimate these supernovae were between about 65 and 500 light-years away from Earth. Although the Earth and the solar system are currently in a safe space in terms of potential supernova explosions, many other planets in the Milky Way are not. These high-energy events would effectively shrink the areas within the Milky Way galaxy known as the galactic habitable zone, where conditions would be conducive for life as we know it. Because the X-ray observations of supernovae are sparse, particularly of the variety that strongly interact with their surroundings, the authors would like to see follow-up observations of interacting supernovae for months and years after the explosion. Thank you for joining us on this journey through the cosmos. If you enjoyed this exploration, give us a thumbs up, subscribe, and hit the notification bell to stay updated on more mind-expanding content. Your support helps us continue unveiling the mysteries of the universe. Remember, out there, beyond the stars, lies the next great discovery. Stay curious, keep wondering, and we'll see you next time on Wormhole to Cosmos.